Good morning, ladies and gentlemen, and welcome to our clip dealing with the modeling of complex plate geometry in IDEA StatiCa. My name is Jacobus Oberholster. I'm an AEC and Procon technical consultant with Micrographics, and you can check my email address there in the bottom left if you'd like to reach out after just watching any of our content, if you have any suggestions or critiques even, or if there's something specific you'd like to see, you are more than welcome to reach out. So let's jump into our clip today where we look at how we can model complex plate geometry in IDEA StatiCa very easily versus using some of the inbuilt functionality that can be quite complex to use at times. All right, so the first thing you need to do is to actually define your geometry in AutoCAD. Now, this can be of any complexity. There really isn't there isn't any limitations that I can think of at the moment. Potentially, if you want to work in a logo cutout, you might have some difficulty with that in IDEA StatiCa, although I would still recommend testing it out if it's actually going to be something that is going to be cut out of the plate itself. So if we look at this plate, what these cutouts could represent are conduits, hydraulic conduits, electrical conduits. It can be anything passing through the plate work that you don't want or that you don't consider to be load bearing, or you don't want it to contribute to the overall rigidity of the connection itself. All right, so I've got quite a few cutouts here. Again, this is just to resemble maybe cutouts where conduits would be running through the plate geometry. Very important is that you save this as a DXF. So you go to save as, you see there's DXF, and hit the save button. Importantly, once you've saved it as a DXF and you close AutoCAD, for some reason AutoCAD will want to now save it as a DWG. Just make sure you click no so that you don't override that DXF accidentally. So what we'll do next is we'll go into IDEA StatiCa and we'll make sure that we close AutoCAD. So you can't actually access that file, or you'll have difficulty accessing that file if you haven't closed AutoCAD. So make sure to do that, and then from there we're going to jump into IDEA StatiCa. In IDEA StatiCa, we're going to start off with a generic connection, so just a blank connection basically, and I'm just going to change their orientation, make the one continuous and the other member like so. All right, so if we go to operations, I'm going to select stiffening plate, and you'll see here is the general state of affairs, right, in terms of the parameters. If I go to editor, if I look at the different functions that are available here, so you can see here if I have a circle or a hole cutout, I actually want to delete this notch. I have a hole. The shape type can be a polygon, and we can start from there. Okay, it seems like it's not updating. I don't know. Let's go square, rectangle, circle. Okay, that seems to not be updating, which is quite unusual. But the point of the story is that it should actually update. But if you use a polygon as your editor, let's try that again. There we go. Okay, you can see there, now it's updated properly. These inputs are incredibly confusing for me. And I don't want to use these inputs because I have multiple cutouts and I can have some pretty strange geometry in a plate for whatever reason. So I'm going to delete this or cancel. And what I want to do is in the shape dropdown, I want to select polygon, and you'll see there is an option to import a DXF. So the first thing is I just want to change the orientation of this plate so that's nice and vertical. I'm going to click on DXF and I'm going to select plate geometry and click open. Right, now this interface opens up, and maybe initially it looks a little bit confusing, but what's nice is it's really, really easy to get used to. So you want to select the outlines, hold down Control to select multiple lines, and then click outline. You can see there it's been generated. In terms of the insertion point, make sure that you select center of gravity versus the DXF origin. Otherwise, it will really mess up the positioning of this plate. What we're going to do next, we're going to select one of the cutouts. We're going to hold down Control key and we're going to select the rest of them. Then we're going to click on opening and that's it. All right, there is what we can expect our plate geometry will look like in IDEA StatiCa now. I'm going to click OK, and there we can see our plate. Now, the first thing I want to do, I have this plate here, so I'm going to leave that there for now. I'm going to create a bottom plate. That's all good and well. I am going to set its width. Let's just see in which direction that goes. So it should be 375 and 375. Of course, I'm aware of what the geometry of this plate should be. That's why I know what these values are. And then it should be, this is 180, so that should be 90 and 90. My Z offset value is going to be 205. And then I can just look from the side and go to the shaded view and make sure that these plates are not intersecting each other. They are on top of each other, which is great. Okay, so I'm happy with that. Now I'm going to select this plate and I am going to position it. So its Y is going to be minus 85. Its Z is going to be 445. And I can see there that it is now relatively neatly on top of that plate. I can move it over. So if I say 1, let's check. So for X or minus 1, I can make a slight modification there. It doesn't always look perfect in terms of these small, very tiny little gaps, but those don't cause any problems in your modeling. Okay, now I want a plate at the back, so I'm going to create a copy and I'm going to set this one as positive 85 and I've got that plate over there. Lastly, I want a cap plate, so I'm going to click on this. The cap plate should again be 90 by 90 and its width is 250 by 250. Its Z value should be 715. And again, we can see there might be a slight little offset there. Okay, that's perfect as it is. All right, now I want a cut operation. So I'm going to go operation and cut. I'm going to select member B and it should be cut by this top plate over here. So let's try that again. That should be like SP4 actually. There we go. For some reason it didn't pick that one up. But okay, there we go. And you can see because the direction is set to parallel, it creates these welds for us to that plate automatically, which is actually quite nice because normally if you want all of these welds, you'd have to add 3 welding operations. If I change this to perpendicular, you see that the welds disappear and I can add an end plate there, depending on how you want to do it. This would technically be some sort of an end plate. It's just easier to do it this way. All right, now I want to add fasteners at the bottom. So I'm going to quickly run through that. So I want to make sure that my first item is this plate and my second item is C top flange. You can see that bolt over there. I'm going to make its position 0 for now. Its rows can be minus 45 and 90. Okay, so these are cumulative, all right? So you can see there I'm from 0, minus 45 is that way. To get a bolt spaced equally in the other direction, it's minus 45 or it's 45 to get to 0, and then another 45 to get to 90. Okay, so that's how the bolts work. Its position, I can do 50 for an offset, and on the other side, I'll just have to do minus 50. But in this case, I'm going to say 100 times 3. Okay, so that is just a little bit too close to that edge for my liking. So I might make this something like 30. Okay, so that's then 330. So If I want to get to 0, it will be minus 330. And then we can do something like minus 360. And we should have that bolt over there. Okay, something like that. And I can do another minus 100 times 3. Okay, that bolt spacing might give me a bit of problems, so I might end up deleting them or something like that. Let's maybe see about making that 0 or just deleting it all together. All right, and then it will be minus, well, actually, yeah, minus 400. Okay, and then it will be minus 100 times 3 times 2, actually. All right, so there, if you look at all of these spacings, you see the spacings are quite decent. So it's 200 in the middle, and I might leave that because I would want to weld a plate in the middle as well. And what we'll do now is just do one weld operation so that we can see how it works. So I'm going to go operation, weld, and contact. And then my member plate or first plate is going to be SP4. And then the second one is going to be something like this plate over here. And I'm going to change this to rear side. Or do it the other way around, because I see this is giving me a bit of problem. So let's rather do it like this and select that guy there. All right, and there we've got our weld on the inside. And you have to repeat this process every single time you want a weld run. And that just takes a little bit of time. All right, so with a little bit of work, what we'll get to is what I'll show you next. So this right here is our final model. You can see all of our welds have been added. If I go to the see-through, you can see there's 2 plates welded in the middle as well. And I've taken care to ensure that how everything has been welded would make sense. If you see all of those welds over there, you can see there's quite a lot of operations here. But in the end, we get it right. And we have our load effects. They are balanced. And we can hit calculate. So if this runs successfully, or the analysis is 100%, it means that our connection works. And if we've got 100% there, we can go to check, look at equivalent stress. I'm not that interested in the deformed model at this stage. And we can see our stress distribution. So we can see those middle plates actually carry most of the stress. So what we might end up doing is thinning these guys out, so making them thinner, and just relying on those middle plates. So these would sort of just keep everything in place. It might even make the welds a bit smaller. But you can see that this works, and that really is the way that you would approach your modeling of complex plates in IDEA StatiCa. So I really hope this has helped you. I hope that this will just speed up your modeling, and that I've opened your mind to the idea of what you could really achieve in IDEA StatiCa Connection with those stiffening plate operations and DXFs. So there's one more clip left. We already have our first clip done and dusted, which is our cost estimation in IDEA StatiCa. You can actually see a cost there. Of course, I mentioned in that clip that I would increase the value per kilogram for steel quite significantly for steel plate work. And that would already be our first clip for the month of July. This is our second clip. And our last clip would look at incorporating something like this in the context of Inventor for detailing. So if you haven't already, please like and subscribe and look out for our other clips as well. Thank you so much for watching, and I hope that you have an awesome day further.